Hi friends, in this video we are going to discuss about stepper motor. Stepper motor nothing but the motor which gives stepwise rotation, the motor which gives stepwise rotation is called stepper motor. Nothing but, that is, it converts the continuous signals into discrete signals. That is, it converts continuous signals into discrete signals. That is called as the stepper motor. Which gives stepwise rotation. They will ask you a question, what is the step angle? The step angle beta is equals to 360 degrees divided by m into n. Step angle beta is equals to 360 degrees divided by m into n, where m is the number of phases, where n is the number of rotor teeth. 360 degrees divided by m into n, where m number of phases, n is the rotor teeth. This is very important question, the step angle. They will ask you a question, a three-phase stepper motor having 12 rotor teeth. 12 rotor teeth. Then step angle is equals to how much? Tell me, what is the answer? The step angle beta is equals to 360 degrees divided by m into n. That is 360 degrees divided by m. Number of phases are 3 and rotor teeth are 12. Nothing but 360 by 36. Nothing but 10 degrees. This is the question they are asking in competitive exams. Three-phase stepper motor having 12 rotor teeth, then step angle beta is equals to. It's very simple question. They will ask you another question. If step angle is 1.8 degrees, step angle given, and the rotor rotating at 100 steps per second. The rotor rotating at 100 steps per second. Then find out speed in RPM. Or RPS. They will ask you a question. What is the answer? The speed n is equals to step angle beta into frequency by 360 degrees. Step angle beta into frequency by 360 degrees. Then what is step angle for this question? They given that 1.8 degrees. Okay. What is frequency for this question? Don't take 50 adjust. Here frequency nothing but they given 100 steps per second. So the answer here 100 divided by 360 degrees, nothing but 180 degrees divided by 360, nothing but 0.5 revolutions per second. Option A is that only, 0.5 revolutions per second. But my question is, what is the speed in revolutions per minute? Getting or not? My question is the speed in revolutions per minute. But the n is 0.5 revolutions per second. Now can you tell me what is answer in RPM? For 1 second, 0.5 revolutions. For 1 second, 0.5 revolutions. For 60 seconds, nothing but 1 minute, how many revolutions? 1 minute. 1 minute, nothing but 60 seconds. For 1 second, 0.5 revolution. For 1 minute, nothing but 60 seconds, how many revolutions? For 60 seconds, 60 into 0.5 divided by 1 is 30 revolutions per minute. 30 revolutions per minute. This is the question, very important. Previous question. Listen, beta given, 100 steps per second given, then find speed in RPM. The formula is the speed n is equals to beta into f by 360 degrees. Beta is the step angle, f is the frequency, 360 degrees. 180 by 360, 0.5 revolutions per second. 1 second, 0.5 revolutions. For 60 seconds, how many revolutions? 60 seconds, nothing but 1 minute. 60 into 0.51, 30 revolutions per minute. This is about the stepper motor. This is about the stepper motor, which gives a stepwise rotation, the step angle beta, and the speed n. Next and very important, applications. What are the applications of stepper motor? What are the applications of stepper motor? Tell me the first one. The first application generally used in printing machines. Printing machines, very important. They asked many times. And next one, this is also used in robotics. This is also used in robotics. And next one, this is also used in rovers. And next one, this is also used in computer peripheries. Computer peripheries. And next one, this is also used in antennas. Antennas, these are the best applications of stepper motor. Printing machines, robotics, rovers, computer peripheries, antennas, control system, and digital system applications. Control system and digital system applications. Generally, we are using the stepper motor. Stepper motor. Here, the two formulas are very important. Once see clearly. Right? Completed? Yeah, stepper motor completed. Up to now, how many are completed? Permanent magnet DC motor, single phase AC series motor, universal motor, shaded pole induction motor, Scratch motor, linear induction motor, stepper motor. Next we have another 3, right? Next one, repulsion motor. Repulsion motor. Next one, repulsion motor. Right? Tell me, repulsion motor nothing but the motor which works on repulsion principle, repulsion of poles. The motor which works on repulsion principle or repulsion of poles. Nothing but here we have a stator poles as well as rotor poles. Stator poles as well as rotor poles. Due to repulsion action, the poles are repelled. The rotor poles are repelled to the stator poles. The rotor poles are repelled to the stator poles. Based on this action, the motor works. So, repulsion motor which works on repulsion of rotor poles with the stator poles. In this machine, the torque T is directly proportional to sine 2 delta, where delta is this angle. Delta is this angle, delta is this angle, the angle between the stator pole axis and rotor pole axis is delta. Torque is directly proportional to sine 2 delta. Can you tell me when we can get the maximum torque? Generally, if it is 90 degrees, we can get maximum torque. Nothing but if delta is exactly equals to 45 degrees, then the torque is the maximum. If delta is equals to 45 degrees, then the torque is maximum. This is very important. In this machine, the starting torque is 3 to 4 times of the full load torque. In this machine, starting torque is 3 to 4 times of the full load torque. Now, what are the applications? Tell me, what are the applications of this machine? Applications of repulsion machine. The applications of repulsion machine: high starting torque applications. Can you tell me examples? Examples again, traction. Refrigerators, traction, refrigerators, etc. These are the applications of repulsion motor, which works on repulsion principle. Torque is directly proportional to sine 2 delta. When delta is 45, torque is maximum. Starting torque is very high. Traction refrigerators, cranes also. Traction refrigerators, cranes. This is about repulsion motor. It's clear? Just applications are very important actually. They will ask you problem only on stepper motor. I given you the 2 problems. Right? Repulsion motor. Next one, reluctance motor. Next one, reluctance motor. Let's see what is reluctance motor. Let's see, reluctance motor. Reluctance motor. Can you tell me what is reluctance motor? What is reluctance motor? For example, if we take a synchronous machine, the synchronous machine, for example, this is my synchronous motor. Synchronous motor generally given by 3-phase AC supply. Synchronous motor generally given by 3-phase AC supply. And rotor given by DC supply. Nothing but excitation. Rotor, nothing but excitation. If this excitation removed, this machine works on reluctance power. If excitation removed, this machine works on reluctance power. Now, the excitation removed synchronous machine is called as reluctance machine. Excitation removed, synchronous machine is called as reluctance machine. This is my reluctance machine. Generally, have an idea of the power equation of salient pole machine? The power equation of salient pole machine is equals to EV by XD into sine delta plus V square by 2 into sine 2 delta into 1 by XQ minus 1 by XD. This is actually power. And generally, you people know already, excitation is EMF is directly proportional to excitation. If excitation is equals to 0, this value is equals to 0. If excitation is equals to 0, this value is equals to 0. Why? If excitation 0, EMF 0. If EMF 0, this value 0. But this value not 0. This value or this power is called as reluctance power. This power is maximum when delta is equals to 45 degrees. When delta is equals to 45 degrees, this power is maximum. So when delta 45, the reluctance power is maximum. This is the power is 0. This power is reluctance power. Very important. Now, generally the doubt. Sir, actually in synchronous machine you said that the excitation removed. But do you know, sir, actually the poles are formed due to reluctance, actually excitation. The poles are formed due to actually excitation. But here you removed the excitation. Then how the rotor poles will form? When the excitation removed for this, the machine absorbs the reactive power from the bus bars. When excitation removed, the machine absorbs the reactive power from the bus bar to produce the poles. Reactive power, which is the main cause to produce the poles. Which produce the poles? Active power or reactive power? Reactive power produce the poles. That's right. The motor absorbs the reactive power from the bus bar to make the poles. That's right. Now another question. Sir, if the excitation removed, the machine rotates at what speed, sir? The reluctance machine rotates at exactly synchronous speed only. The reluctance machine also rotates at exactly synchronous speed only. Synchronous speed only. This is also rotates at synchronous speed. Get it? Now, finally, what are the applications? What are the applications of this machine? What are the applications of this machine? Tell me, what are the applications? The applications are low constant speed. Low constant speed applications. Low constant speed applications. Which are the examples, sir? What are the examples? Generally, these are used in analog meters. Analog meters. And these are used in timers. And these are used in counters. Analog meters, timers, counters. And these are used in XY recorders. XY recorders. What are XY recorders? Like a CRO, ECG, CRO, ECG, like that. The applications, low constant speed applications, analog meters, timers, counters, XY recorders, those are CRO, ECG, etc. This is generally the reluctance motor, very important, the reluctance motor. The excitation removed synchronous machine is reluctance motor. See once clearly. Hysteresis motor, last one in special machines, hysteresis motor. Hysteresis motor works on hysteresis principle. Hysteresis motor works on hysteresis principle. Hysteresis motor works on hysteresis principle. Generally, in these hysteresis motors, the core made up of, or the core should have high reluctance and high retentivity. High reluctance and high retentivity. The motor should have, the machine core should have high reluctance and high retentivity. What is the example of that material? Generally the chromium steel. Chromium steel used for this core. Chromium steel used for this core, which having high retentivity, high reluctance. Right, next one. Hysteresis motor applications. Hysteresis motor applications. The applications of hysteresis motor. Generally, hysteresis motor used for low constant speed. Low constant speed applications. Low constant speed applications. Example, watches. Wristwatches are generally watches. And generally used in photography turntables. Photography turntables. Photography turntables. and generally used in tape recorders, watches, photography turntables, tape recorders, etc. These are the applications of hysteresis motor. Photography turntables, watches, tape recorders, etc., which works on hysteresis last principle, the core made up of chromium steel, which having high reluctance and high retentivity. These are generally the special machines of induction machine. Not only induction machine, DC machine, synchronous machine. All special machines. Permanent magnet DC motor, single phase AC series motor, universal motor, shaded pole induction motor, linear induction motor, Scrase motor, stepper motor, repulsion motor, reluctance motor, hysteresis motor. These are the special machines. Right? Let's see them.